All right, everybody, we're going to talk about polar coordinates today. We touched on these a little bit when we talked about trig form, which is also called polar form. You might recall, you might not. But hopefully some of this stuff kind of sounds familiar. But the graphing system you've been using up until now has been the Cartesian coordinate plane or the rectangular system. X and Y, you move right, left, up, down. That's rectangular motion. On the polar graphing system, instead of x and y, you have r and theta. I like to think of it as radius and a theta value, radius and angle, which is how it was related to our trig form, or polar form of complex numbers, which was also called r cis theta. So the r and theta were mixed in there. Notice this, the graphing plane, the polar plane, is a series of concentric circles. But the same, it's really just right on top of the rectangular plane, where that would be 1, 2, 3 on the x-axis. That's a circle with a radius of 1. That's a circle with a radius of 2, etc., etc. And you'll notice these lines are drawn, it's drawn to scale, so this 90-degree quadrant is broken up into thirds. That's 30 degrees, 60 degrees, or pi over 6, pi over 3. Pi over 4 would be right smack dab in the middle, and so on and so forth, all the way around. So plotting a point on the polar plane, the first coordinate always represents your r, or your modulus. The second coordinate represents your theta, or your angle. And so 4 comma 2 pi over 3, you can think of it as going doing the radius portion first, if you like. So that would be going 4 to the right, 1, 2, 3, 4, a radius of 4, and rotated an angle of 2 pi over 3, which would be right here in the second quadrant. Some people like to think of the angle first as, rotate the 2 pi over 3 and then go out positive 4 units. Either way, you're going to end up in the same spot, no particular order. When you have a negative angle, so this time positive r, negative theta, that would be a radius of 2, rotated 7 pi over 6 in the negative direction. So, time to brush up if you're a little rusty with that. That would be negative pi and a sixth. We're right about there. And there we go. Negative 5 pi over 6. So now your r value is negative, which is a little weird if you're thinking of that as a radius, because you don't normally think of a radius as being a negative value. But in this case, you can think of it two ways. One, if you like to think of doing the r value first, now it means go 5 to the left. 1, 2, 3, 4, 5, and go pi over 6 from there. So starting from there, going positive pi over 6 means going in this counterclockwise direction, an angle of pi over 6, and that will put you right there. If you like to think of the angle first, which many people do, no big deal, you'd be thinking of, okay, here's pi over 6, this is the line that's pi over 6, but now going 5 units backwards. Instead of going 5 units out, 5 units behind, so backwards direction. It'll put you right on the same spot, 1, 2, 3, 4, 5. And when they're both negative, it's no big deal. If you've gotten this far and handled it okay, it's just putting both ideas together. Negative 3 pi over 4, 3 to the left, and then going 3 pi over 4 in the negative direction, so clockwise. So 3 pi over 4 starting from here will put you right there. If you like to think of the angle first, okay, so negative 3 pi over 4 would be going 3 pi over 4 here, and then going 3 units backwards. 1, 2, 3. 3 units back from there. Same spot, either way. And so let's just do a little practice here. 5, 7 pi over 6. 1, 2, 3, 4, 5, and then 7 pi over 6. So 7 pi over 6 in the positive direction, as always, is going to put us right there. Notice the directions say to plot that point and give 3 additional polar representations of that point. The good thing about polar graphs and trig functions, there's more than one way to get to that spot. We know all about coterminal angles. So there's actually an infinite amount of answers you could give me. One would be, say, going positive 5, 1, 2, 3, 4, 5, but going in the negative direction to get there. And going in the negative direction to get there would be negative 5 pi over 6. And you might just say, hey, that's just taking 7 pi over 6 and subtracting 2 pi. Coterminal angles, add or subtract 2 pi. So that is one possible option. How about using a negative r value, which, by the way, I could also keep r the same and add 2 pi to 7 pi over 6, and you really could do that an infinite amount of times. But how about trying one with a negative r value just for practice? Going negative 5, so 1, 2, 3, 4, 5 to the left to start, and then to get to there, I really only have to go pi over 6 in the positive direction. So that would be one other way to get there. And then how about just another one to practice with a negative r value? This is a totally new graphing system, and that's usually the part, if anything, that bugs people a little bit. 1, 2, 3, 4, 5. I could do this and then add 2 pi to that, pi over 6, or I could start from here and go this amount in the negative direction, and that would be going negative 11 pi over 6, or in other words, pi over 6 minus 2 pi. So once you have one that works, you really can just add or subtract 2 pi to the theta value over and over again. And now let's just try this last one here, and that'll be good for today, breaking in a totally new graphing system. And then once we can plot points, we can make graphs out of them, and that's when you get those funky circular graphs that we've glanced at here and there. Negative 3, negative 5 pi over 3. So negative 3 and going 5 pi over 3, but in the negative direction, so going clockwise. So 5 pi over 3 would be going that far right there. Right? Or, again, go 5 pi over 3 in the negative direction first. Or if you like, you can convert that to degrees. That's negative 300 degrees. And then going negative 3 from that line. So 1, 2, 3. Instead of going out, going backward. So there's the point. And now can we get there? A couple other ways? Sure. How about we keep the r value the same, negative 3, and then we get to here a fast way. We're going positive pi over 3 from that spot. We'll give you the same location. How about with a positive r value? Because I could just take this pi over 3 or this negative 5 pi over 3, and I could add 2 pi over 3, subtract 2 pi over 3 an infinite amount of times. But let's try it with the opposite r value to get comfortable going back and forth. So a positive r value of 3, one way would be to rotate in that direction, and that would be 4 pi over 3 in the positive direction. Or positive 3, but go in the negative direction angle-wise, so that would be 3 negative 2 pi over 3. And those are just 3 options. Again, you really could give an infinite amount of answers, but that was just a little variety with changing r to positive to negative and theta positive to negative. So just trying to get you comfortable with it. If you don't like this, I'm sorry, you just have to grin and polar bear it. Sorry kids, it's terrible. But have a nice day. Hit me up with any emails if you got any questions.